I'm Jean-Luc, and this is an electrocardiograph I built. So how does an electrocardiograph work? An electrocardiograph, or EKG, is a device that can sense the voltage generated over time by a heart. Amplification and filters are used to specifically pick out a heartbeat from the surrounding noise. The result of the signal processing is then shown on an oscilloscope. The EKG I made was for a Virginia Tech engineering class. This is an overview of the entire EKG system. This first element is known as an instrumentation amplifier, or IA. It has the characteristics of high input impedance, while also having the ability of amplifying the signal. In this case, the gain is 15. Two signals are inputted into the IA. The output of this element will have the difference between the signals while also amplifying the difference by 15. The signal then travels to an active high-pass filter that will pass the high band of frequencies while also getting rid of the low bands. The amplification for this high-pass filter is 100, and the cutoff frequency starts at 0.5 Hz. After a high-pass filter, a low-pass filter is added to get a frequency range of a heart. A normal heartbeat is usually 60 to 100 beats per minute, or 1 to 2 Hz. A notch filter is then added to cut out the 60 Hz power supply frequency. After all those elements are added in the circuit, the output for the oscilloscope should output a heartbeat. Now back to the circuit I made. If you look at the signal, you will notice a lot of noise. I believe this noise is coming from the 60 Hz power supply. When I was unit testing my circuit, I encountered this noise, so I put bypassing capacitors to prevent noise from the power supply, but this didn't work. So what's the issue then? If you look closely, you will notice that I put a jumper wire over top of a negative VCC lead. It wasn't until after I filmed and was looking over the film that I realized that the noise is probably coming from the electromagnetic interference of these two wires being in close proximity. The wires that I was using are not shielded, which means that the 60 Hz on the negative VCC wire was being transmitted to the other wire, and this I believe is what caused the interference. Other than the noise, I also noticed that the amplification of my circuit is not exactly 15,000. A heartbeat usually produces 1 mV signal, so with the 15,000 gain, this should produce a 1.5 volt signal. However, with the circuit I built, I only got 180 mV, and to this I believe the answer is in the resistor values that I use, and something else that I still haven't figured out yet. The tolerance for my resistors is roughly plus minus 5%. The IA and the other filters are very sensitive to resistor values. A couple of ohms can throw off a result a lot. I did add resistors in series to combat this issue, however the space on the breadboard was limited, so usually only 3 resistors could be added to combat this. Because this was the case for all my resistors, I believe this resulted in a decreased amplification. Now I don't believe it was just the resistor values, I do believe it was something else as well. And the reason I believe this is because when I was getting the frequency response of the entire circuit, the voltage would swing up to 1 volt, but then would go back to 180 millivolts. I never figured out the issue, and wasn't sure if it was a bad op-amp or something else. Other than those issues, however, I'm very pleased to have worked on this project. I learned so much on circuit design and troubleshooting, and I look forward to making more signal processing circuits in the future. If you liked this video, make sure to click the like button, and if you loved it, subscribe. I make videos on projects I've worked on, or just videos that teach something that I find fascinating. I'll see you guys in the next one. Peace.